Okay, a little easier to understand if it's written out than if I'm waving my hands over it. So the complication for this one is that you don't have the omega in your numerator. Okay? But in the table, sine of omega t goes with omega over s squared plus omega squared. Omega is just a constant. It's not, s is the variable in your Laplace transform. Omega is just a constant number. So we can always do a constant times this to get something that doesn't have our omega up here. Well, we can write down that in this case, very clearly, omega is pi over 2, because we have the pi squared over 4 here where omega has to be. So there's no choice but that omega is pi over 2. So pi over 2 over s squared plus the quantity pi over 2 squared is the Laplace transform of the sine of pi over 2. Okay, so what's the Laplace transform of 1 over this? Well, 1 over s squared plus pi over 2 quantity squared is 2 over pi times pi over 2 over s squared plus pi over 2 quantity squared. Okay? And what do you have to multiply this by to get this? 2 over pi would be a good idea. So that, again, the more room here. So 1 over s squared plus pi over 2 quantity squared. That's a little hard to read, but you know what I'm writing. I'll write it this way, is the Laplace transform of 2 over pi sine of pi over 2t. And this d over 12 thing, yeah, just kind of ignore that. That goes with something else I was doing here. And there are other ways to set that up. They're all pretty obvious. You just got to understand how to work it out and how to match up the form of the Laplace transform you have with a form in the table.